Hello guys and welcome to Geometry. I'm your host today. My name is Mr. Rao. It is so good to see you. We got section 7.4 today, which is all about special right triangles. In this section we are going to study two particular right triangles that are called special right triangles because of their commonly used angles. The first triangle is formed when a square is cut in half, and the second one is when an equilateral triangle is cut in half. So the first one is called a 45-45-90 triangle. It's named after its measure angles. It's an isosceles right triangle. Remember, isosceles means it has two sides that are equal. And it is formed when cutting a square in half. So to draw this, what I'm going to do is I'm going to draw a square. It's a terrible square. Let's try again, Mr. Rao. That's better. We're going to call that a square. And what we do is when I cut this in half diagonally here, it creates two right triangles, and both of those cuts the angles in half. So instead of 90, that's going to be 45 over here and 45 down here. And the last one is 90. We know that it is isosceles because all sides of the square are the same. And then we have the hypotenuse, which is a little bit longer. So drawing this just separately, it's any right triangle that is isosceles, meaning that both sides are going to be congruent, 45 and 45 for the angles, and 90 for the last one. And what the theorem states here is that the length of the hypotenuse is read 2 times the length of its legs. Recall that the legs are the same since it's isosceles, so it doesn't matter which leg length you use to determine the hypotenuse. So in this case here, what I would call, if this is x and this is x as well, because it's isosceles, this has to be x multiplying it by rad 2. Another way that we could say it is that the hypotenuse is equal to the leg times rad 2, or you could say that the leg is equal to the hypotenuse divided by rad 2. So a quick example here for you. I'll make a nice easy one. This is 90-degree angle. Those are congruent. We'll call each one of them 8. What is the hypotenuse here? That would mean that x has to be 8 rad 2. The other special right triangle is called a 30-60-90, and it's named again for its angle measurements. There's going to be 3 angles, and they're going to be 30, 60, and 90. And it's formed when taking an equilateral triangle and cutting that in half. So let's see if Mr. L can draw an equilateral triangle. Much better job there. All the sides are congruent there. But when I cut it in half down the middle, what that means is I create a 90-degree angle here. And this is going to be our 30, 60, 90 triangle. So I'm going to draw it bigger down here. And I'm actually going to move it separately. So I'm going to take this triangle and I'm going to rotate it kind of 90 degrees. I'm going to rotate it so this bottom side here is now the bottom side over here. We got 30, 60, and 90. Remember that across from the 30-degree angle is the shortest leg, short leg. Across from the 60-degree angle is the long leg, and across from the 90 is the hypotenuse. So what we know from this theorem is that the hypotenuse is going to be 2 times the short leg. So it's literally doubled the short leg. Or we know that the long leg is going to be equal to the short leg times radical 3. So a quick example of this would be, let's say I have the short leg is 2. I know that this is going to be 30 here, 60 here, and 90. What are x and y? So x is the long side, so I would take the short side and multiply it by rad 2 to get 2 rad 3 for the long side, and the hypotenuse is 2 times the long side, so that's 2 times 2, which would give me 4 for that length. Let's do a quick couple examples to get an idea of how this might work. Here is a isosceles. I know it's going to be a 45-45-90 triangle. If the legs are 3 rad 2, what is the hypotenuse going to be? We'll call that x. x is going to be equal to 3 rad 2, which is the leg, times rad 2 to get the hypotenuse. And when I do that, I get x is equal to, well, rad 2 times rad 2 is just 1 regular. And finishing that up, I would have 3 for this, so 3 times 2 would give me that this side is 6. Okay, another example. What if I was given that the hypotenuse was actually 5 rad 2? If that was 5 rad 2, I would know that the leg is equal to the hypotenuse divided by rad 2. So leg is equal to, in this case, 5. So both of these are going to be 5. And one last one here. Let's say I was given that the hypotenuse of a 30, 60, 90. Oops, that's going to be the 60 side. This is the 30 and the 90. Say the hypotenuse is 4. So to find that, we always want to find the shorter leg first. And when we find the shorter leg, that's going to be half of what the hypotenuse is. That's hypotenuse divided by 2. So that's 4 divided by 2, which is 2. So that's the leg here. The short leg is 2. And to find the long leg, I would take the short leg. So long leg is equal to the short leg times rad 3, which would give me 2 rad 3 for the long leg.